Hey guys, we're going to go over the study guide here. So just follow along and see what you got right, and hope these explanations help you. Number one on the study guide, we'll see we have what is the theoretical probability of getting a 5 or 6 when rolling a number cube. So all we're saying is theoretically what should happen when we do these things. So we have the probability of rolling a 5 and the probability of rolling a 6. Oh, I'm sorry. 5. Probability of rolling a 5 is 1 out of 6, not 1 out of 5. And then rolling a 6, also 1 out of 6. And here we know rolling a 5 and rolling a 6 are mutually exclusive outcomes here. They can't happen at the same time. And we're only rolling the number cube once. So all we do is add these together to get our answer here. 1, 6 plus 1, 6, 2, 6. And you'll notice it doesn't match any of our answer choices. That's because we need to simplify and get this to be 1/3. And now we have an answer. Letter A. Perfect. Moving on. Sam has a bag of blue and orange pieces of candy. There are 14 orange pieces and 16 blue pieces. Sam eats 4 blue pieces. Now, what is the probability of Sam randomly choosing a blue piece and then an orange piece as her next 2 pieces of candy? So, how many pieces of candy total do we have? First thing we need to know, 14, 16, that's 30. But then, she eats 4 blue pieces. So the new total, minus 4, 26 pieces. Ugh, terrible. There we go. And they were all blue. So before we had 14 orange, 16 blue. Now we have 14 orange and only 12 blue because she ate 4 of them. Now what's the probability of her choosing a blue piece and then an orange piece as her next 2 pieces? Well, we have 2 different selections going on. We know we're going to multiply these fractions. First, the probability of choosing the blue, so 12 out of 26. Obviously, she's eating the piece, so it can't be replaced back into the pile, or the bag, rather. So the next probability of getting an orange would be 14 out of 25. And then you multiply these together. So calculator here. We have 12 times 14, 168. And then we have 26 times 25, 650. Just like that. And as you can see with the answer choices, you can reduce that to 84 out of 325 by dividing both these by 2. Simplifying these fractions is a lot easier once you have choices to pull from. You can see where you think this fraction you start with is going to go. Here, number 3, a spinner has 10 equal size sections numbered from 1 to 10. If you spin the spinner, what is the probability that the number you spin is a multiple of 2 or a multiple of 3? So let's make a Venn diagram here. You can see we're probably going to need one. Like that. And we'll have a multiple of 2, multiple of 3. Just like that. So the multiples of 2 on a spinner would be 2, 4, 6, and 8, and 10. And multiples of 3, 3, 6, 9. Is there a number that shows up both places? Yes, there is. 6. So what we want to do is kind of scribble those out and write it one time in the middle, so we're not counting it twice. And then our total possible outcomes now that fit these criteria would be 1, 2, 3, 4, 5, 6, 7. out of 10. And that's it. Letter C. Perfect. S and T are mutually exclusive events. If probability of S equals 2/5 and probability of T equals 1/7, find the probability of S or T. Well, although the symbols and the notation here might seem a little confusing, all you need to do here is you know that they're mutually exclusive, so you just take these fractions and add them together. 2/5 plus 1/7. The only hurdle here is that you need to get common denominators before you can add these fractions. So I'm going to multiply this fraction, 7/7, and this fraction by 5/5. And then I get new fractions, 14/35 plus 5/35. And then you get 19/35, which is letter B. So once you know what the notation and the terminology means, really simple stuff there. Number 5. In the experiment, a 6-sided die is rolled numerous times. The table below shows how many times each number on the die appeared as a result of a roll. So here on the left, we see the number on the die. And on the right, we see the number of times that that number on the die showed up facing up when we rolled the die. Okay, so if we look down here, the question itself is down here. Based on the results of the table, what is the experimental probability of rolling either a 3 or a 6 with only one roll? So obviously, rolling a 3 and rolling a 6 are mutually exclusive outcomes. We can't do those at the same time. So we find the probability of each one, and then we add those probabilities together. So first, we need to figure out how many rolls there were, right? Have to do that. So 9 plus 6 is 15, plus 3 is 18, plus 4 is 22, plus 8 is 30, plus 6 is 36. So I'll jot that down here, 36 rolls. We rolled the ball. We rolled the die 36 times. So experimental probability is just saying we're going to look at how many times we rolled these numbers and just use that as our probability instead of making a prediction. So we rolled the number 3 times. So that was 3 out of 36 times that happened. So that's the number 3. And the number 6 was rolled 6 times. 6 out of 36. And then we add them together. And we get 9 out of 36, which is 1/4. Letter A. Okay, right up here. Letter A. There we go. Awesome. Number 6, about 18% of the US population is under 25 years old. About 11% of the population is over 70 years old. What is the probability that a person chosen at random is under 25 or over 70? Write your answer as a percent. So let's make a number line to make this a little more clear. We have 25 and we have 70. So the probability of someone chosen at random is under 25 on this side here or over 70 over there. So you can't be both at the same time, so there's no overlap here. So what we need to do is find these probabilities and add them together because they're mutually exclusive. We don't have to do anything with the Venn diagram where we find which values overlap there. And luckily for us, the question actually gives us these probabilities. 18% under 25, 11% over 70. So the probability that one single person chosen at random is under 25 and over 70, well, that would just be 18% plus 11. And that gives you 29%, which is letter D. Open response. So we no longer have multiple choice here. Last question on the study guide. In the survey, the 30 students in the class were asked 2 questions. Each asked 2 questions. Do you have a sister? Do you walk to school? 17 students said they have a sister, and 24 students said they walk to school. Assuming all responses are independent of each other, so these questions didn't have any effect on each other, they were asked independently, they had no relationship in terms of the answer to one question would affect the answer to another question. What is the probability that a randomly chosen student has a sister and walks to school? So we take 17 out of 30, right there. 17 out of 30. And then we have to multiply that by, where's 24 out of 30. These are independent events. So it's still 30 out of 30. And we get 30 times 30, 900. 17 times 24, 408. And we can simplify that. We get 204 over 450. We can simplify that again. Just going to keep dividing by 2 because that's the easiest thing to do if you're not sure where to go. 102 over 225. And that would be it right there. 102 over 225. Can't simplify that more. What is the probability that a randomly chosen student does not walk to school? Well, we know that 24 walk to school, so then there would be 6 who don't walk to school. So 6 out of 30, which is 1/5. And there's your probability. Just taking the 6 who don't and putting it out over 30. And that concludes our study guide. The rest of it's in Spanish. So hope this video was helpful for you. Feel free to watch it as many times as you like. And good luck on the test. See you guys when I see you.